Hello and welcome to this session. In today's session, we will delve into simulation of a simple electronic and power electronic circuits using LT-SPICE. This simple electronic circuit converts alternating current to direct current, and power electronic circuit can increase or decrease the input voltage.
Objectives. At the end of this session, you will be able to construct the full wave rectifier using simulation software and construct the chopper circuit using simulation software. Introduction to rectifiers. A rectifier is an electrical device comprised of one or more diodes that allow the flow of current only in one direction. It basically converts alternating current into direct current. See the different types of rectifiers. They are half-wave rectifier and full-wave rectifier. Let's see each of these in detail. Half-wave rectifier. The half-wave rectifier is the simplest type of rectifier and consists of a single diode, an AC source, and a load resistor. Full-wave rectifier. Full-wave rectifiers rectify both halves of the input AC waveform, resulting in a smoother DC output compared to half-wave rectifiers. There are two main types of full-wave rectifiers: center-tapped and bridge rectifiers. Now let's see what are chopper circuits. Chopper circuits, also known as DC to DC converters or switch mode power supplies, are electronic circuits used to control and regulate the conversion of DC voltage from one level to another. Types of chopper circuits: step-down chopper or buck converter and step-up chopper or boost converter. Let's see each in detail. Step-down chopper. In a buck converter, the output voltage is lower than the input voltage. Step-up chopper. A boost converter increases the output voltage above the input voltage. Next, we will look at the construction of a simple electronic circuit and power electronic circuit using simulation software. For this, you will need the following tools and equipment such as personal computer and simulation software installed in the personal computer. Now let's construct the full wave rectifier using simulation software. First, open the simulation software that is pre-installed in the PC. To create a new file, click on New Schematic. Now let's place the required components for the construction of full wave rectifier. For that, we need inductors, diode, resistors, and a voltage source. For placing the component on the schematic, select the component on the menu bar. Tip: for placing component, you can type P on your keyboard. In the search box, type voltage and click on Place the component on schematic. Next, search for the inductors in the components dialog box for that type of inductor and place it on the schematic. Here, we need 3 inductors. So repeat the steps again. And click Ctrl+R to reverse. Next, search for the diode in the components menu or simply press D as keyboard shortcut. Repeat the same for the rest 2 diodes. Next, search for the resistor in the components menu or simply press R as keyboard shortcut. Now to place ground, simply press G on the keyboard and place it on the schematic. After placing all the required components on the schematic, begin wiring between the components. For wiring, go to the menu and select option Wire. Tip: for wiring shortcut, click W to start wiring. Now wire up according to the circuit diagram and connect to the ground. Next, we need to fix the voltage specifications. For that, first right-click on the voltage and click on Advanced. Select the sine mode for generating the input signal. Now fill the columns. Here, we choose the offset value as 0 volt, amplitude as 230 volt, and frequency as 50 Hz. Now select the series resistance value as 0.1 milliohm. Next, we need to fix the inductance value. For that, first right-click on the inductor. Now fix the first inductance value as 1 millihenry and click OK. Now again right-click on the second inductor and fix its value to 40 microhenry and click OK. Right-click on the inductor and fix its value to 40 microhenry and click OK. Next, we need to fix the resistance value. For that, first right-click on the resistor. Now fix the first resistance value as 10 kilo ohm and click OK. Now we need to fix the diode specification. For that, first right-click on the diode and select the option as Pick a new diode. Then, a drop-down list appears and select the diode 1N4148 from the list and click OK. Repeat the same for the next diode also. Now we need to specify the coupling coefficient. For that, first click on the Edit option and then select the SPICE directive. Then type KL1, L2, L3, 1, where K is the coupling coefficient, L1, L2 and L3 are the labels of the inductors, and 1 represents the value of the coupling coefficient. Before testing the circuit, make sure that all the connections are correct. Now let's test the circuit. For testing, first we need to determine the duration of the simulation. For that, first click on the Configure Analysis icon or press A as keyboard shortcut. A dialog box appears. In that, select Transient and type the stop time. Here, we set the stop time as 0.2 to see 5 cycles. That is, number of cycles divided by frequency is equal to stop time. Now we can run the simulation. For that, click on the Run icon or press Alt plus R as keyboard shortcut. Now we can plot the input and output waveforms. For plotting the input waveform, place the cursor on the wire connecting the input voltage. The input waveform is getting plotted. Now we can plot the output waveform on a separate plot plane. For that, first right-click on the mouse and select the option as Add a plot plane below. Now to plot the output waveform, click on the wire connecting the resistor as diode as shown. The output waveform is getting plotted. Now let's construct a power electronic circuit. Here, we will construct a step-down chopper circuit or buck converter using the simulation software. First, construct the chopper circuit according to the circuit diagram given. Place all the components and wire accordingly. Wire according to the circuit diagram. Now we assign values for each component in the circuit. Input voltage V1 is equal to 50 volts and click OK. Inductance is equal to 50 microhenry and click OK. Capacitance is equal to 100 microfarad and click OK. Resistance is equal to 1 ohm and click OK. Next, we need to fix the voltage specifications. For that, first right-click on Voltage and click on Advanced. Select the pulse mode. Now fill the columns. Set the initial voltage as 0 volt. V on voltage is equal to 12 since we are using gate source voltage. Most MOSFETs can accept voltages between 5 to 20 volt. Time delay is equal to 0. Set the rise and fall time as 1 nanosecond. time on is equal to 0.3 multiplied by 10 microseconds. Time period is equal to 10 microseconds and click OK. Now we need to fix the diode specification. For that, first right-click on the diode and select the option as Pick a new diode. Then a drop-down list appears and select the diode MBRS1100 from the list and click OK. Now we need to fix the MOSFET specification. For that, first right-click on the MOSFET and select the option Pick a new MOSFET. Then a drop-down list appears. Select the preferred MOSFET from the list and click OK. Now let's test the circuit. For testing, first we need to determine the duration of the simulation. For that, first click on the Configure Analysis icon or press A as keyboard shortcut. A dialog box appears. In that, select Transient and type the stop time. Here, we will set the stop time as 0.15 milliseconds. And click OK. Now we can run the simulation. For that, click on Run icon or press Alt plus R as keyboard shortcut. Now we can plot the input and output waveforms. For plotting the input waveform, place the cursor on the wire connecting the input voltage. The input waveform is getting plotted. Now we can plot the output waveform on a separate plot plane. For that, first right-click on the mouse and select the option as Add a plot plane below. The output waveform is getting plotted.
This brings us to the end of this session. In this session, we have learned to construct the simple electronic circuit using the simulation software and construct the power electronic circuit using the simulation software. Thank you for watching. We will see you in the next session.